Welcome to our tutorial Proflan YouTube channel. In this particular video, we're going to discuss how you can be able to work out area of shaded region using. In question number 1, we're given the equation of a curve, and this curve moves like that. And the equation of this curve is y equals to 2x minus x squared. And then you are supposed to work out the area of the shaded region here, whereby the shaded region is bounded by the curve and the x-axis. If you are new to Proflan YouTube channel, consider subscribing so that when I upload another tutorial, you'll be notified. In Proflan YouTube channel, we do maths, and physics. If you are taking EdExcel, you are taking Cambridge, both physics and math, O-level, AS physics and A-level physics, we got you. Consider subscribing and also leave a comment if there's any video you like us to upload. Now, for you to work out this particular question, remember we're going to use integration, and in order for you to integrate this curve, you need to know what is the limits. So, and our limits are going to be 0 and this x coordinate we have at this given point. Now, for you to get the, of course, here we have the lower limit, which is 0, the upper limit we don't know. We are going to solve this equation, and we're going to say now 2x minus x squared is equals to 0. So this is the equation we are going to solve in order to know what is this coordinate at this point, the x value of this coordinate. And we shall start by factoring x out, and we shall have x, we shall have 2 minus x is equals to 0. Now at this point of time, we are going to say now our x is equals to 0, or 2 minus x is going to be equals to 0. So the first value of x is this value that we have at this point, and the second value of x is going to be 2 is equals to x, because if you take this x on the other side, you are going to have 2. So meaning this coordinate that we have here is 2 and this one is 0. Now, how do you use integration in order to proceed from this particular point? Because if you integrate the graph, the curve from 0 all the way to 2, the curve 2x minus x squared with respect to x, we are going to find the area under the graph, and the area is this part that is bounded by the curve and the x-axis. So to do that, we are going to say we are going to integrate this term, and integrating that term becomes 2x. You increase the power here, which is 1 by 1, become 2, then you divide by 2 at that point, then minus, this is x squared, you increase the power by 1, and that becomes x power 3 divided by 3. All right, and then now you are going to ignore, because when you integrate you are supposed to say plus c, but now since this is a finite integral, you are going to ignore the constant, and then you write the limits 0 and then 2 at that point. Once you have achieved this point, we are almost home and dry. So of course, now we are going to substitute to the upper limit anywhere you have x in this expression, and the expression is going to 2 and 2 will cancel out, and then now we are going to have our expression simplifying to 2, this 2 here raised to power 2 minus 2, this 2 here raised to power 3 over 3 minus, now substituting the lower limit, it will be 0 raised to power 2 minus 0 raised to power 3 over 3. So you can see this will become what? This will become positive 4, and this will become 8 over 3. So this would be 4 minus 8 over 3, then minus 0. So if you try to simplify this, you can see we end up having our answer as 4 over 3. Our answer is going to be 4 over 3 square units. And this represents the area of the shaded part. Now, we're going to look at a second scenario here, whereby you have the curve, and the equation of the curve is y is equals to e is to x over 3. This is the equation of the curve. And there is a tangent to the curve at point P, where the coordinate of P is 9e is to 3, and the tangent cuts the x-axis at the point R. So we are supposed to work out the coordinate of the point R and also find the area of the shaded region at this point. Now, the first thing we're going to do in order to work out the area of the shaded region is to work out the equation of the tangent. And for us to work out the equation of the tangent, we need to know what's the gradient of this curve, what's the gradient of the curve at the point where the tangent touches the curve. So meaning that for us to know the gradient of the curve at this point, we are going to do dy dx of this curve that we are given. And remember, the curve is e is to x over 3. So if you differentiate, if you are given y is equals to e is to x over 3, then meaning if you differentiate this, you are going to get 1 over 3 e is to x over 3. That's what you do when you find derivative of exponent. You differentiate the exponent, the power, multiply it behind the exponent. Now, then for us to know what's the gradient of this curve at this point P, we are going to evaluate dy dx at the point where x is equals to 9. At this point, x is 9. So we are going to substitute it into the gradient function that we have obtained at this point. And then this is going to be 1 over 3 e is to 1 over 3 times 9. And if we work out this is going to reduce to what? This is going to reduce to 1 over 3 e is to power 3. Now, this is the gradient of the curve at this point. And since this line is a tangent, then the gradient of the line at the point P is also the same as 1 over 3 is to 3. Then now we need to find equation of a straight line takes the form y is equals to mx plus c. That is the equation of a straight line. Then in that point, we know that m is the gradient, c is the y-intercept. So we're going to say this equation will be of the form y is equals to the gradient. We have it here because the gradient of the curve and the gradient of the tangent, they are equal. So we're going to say this is 1 over 3 e is to 3x. This is the gradient, then plus c. So in order to find c, we are going now to substitute x to be 9 to this equation and y to be e is to 3. So we are going to say e is to 3 is equals to 1 over 3. E is to 3 and our x is 9 in that case. Then we shall say plus c. So which will mean that we are going to cancel this and this. We have 3, so we shall have e is to 3 is equals to 3 times 3 e is to 3 plus c, which implies that c is equals to, if you take this on the other side, it will be negative 2 e is to 3 at that point. That is the y-intercept of this curve. Then the equation of the curve now reduces to y is equals to 1 over 3 e is to 3 x minus 2 e is to 3. Now this is the equation of this tangent. For us to know the coordinate of r, we are going to say for this equation of the tangent, r, which is the x-axis, the point on the x-axis, any point on the x-axis, y is always equals to 0. So we are going to substitute 0 here so that we can be able to find what is the x coordinate at this point. So we can now say at x-axis, we need to remember that at x-axis, y is always equal to 0. You take that to the bank. That on the x-axis, at the x-axis, y is always equal to 0. And then we are going now to go ahead and solve this. We are going to say 0 is equals to 1 over 3 e is to 3 x minus 2 e is to 3. Then we're going to take 2 e is to 3 on the other side. 2 e is to 3 is equals to 1 over 3 e is to 3 x. If we can see and open our eyes widely, we can see that e is to 3 and e is to 3 will cancel out. Then we are going to multiply 3 both sides, and we're gonna end up having our answer equals to 6, our x equals to 6. So in this point here, the x value is now 6. But if we drop a line from this point up this point here, right, we are going to have our x coordinate here equals to 9. Find the area of the shaded part for the curve. If we integrate from 0 all the way to 9, if we integrate from 0 all the way to 9, we'll be working out the area including this triangle, shaded area of the shaded region plus the area of the triangle. If we integrate from 0 to 9, the equation e is to x over 3 with respect to x, this will be giving us the area of the shaded region, originally shaded region, plus the area of this triangle. So we are going to do that, then later on we're going to subtract the area of this triangle. So let us first integrate. Integrating this, remember, when you integrate exponent, you differentiate the power, then divide it. So we are going to say, differentiating the power, we're going to get 1 over 3. So the final answer becomes e is to x over 3 over the answer we get when you differentiate, and that's going to be 1 over 3. Working that from 0 all the way to 9. But if you simplify to reduce to 3, e is to x over 3, and we are evaluating from 0 all the way to 9, which will mean that if we substitute 9 here, it's going to be 3 e is to 9 over 3 is the same as 3. 9, because here you are going to substitute 9, it will be 9 over 3, which is going to reduce to 3. minus substituting 0 to this to be 0 over 3. It will translate on, of course, our 3 is here, to be 3 is to 0. And this means that this is 3 is to 3 minus e is to 0 is 1. So we shall have our 3 at that given point. So this is the area of the shaded region plus the area of the triangle, this part that we have here. Now, of the shaded region, we need to know what's the area of this triangle that is at this point. Now, to find the area of this triangle, straightforward. Let me just make use of the space that we have here so that I can be able to show you exactly what you are supposed to do. And if you are new to Prof Learn YouTube channel, consider subscribing so that in time I'm going to upload another tutorial, you'll be notified. Take a moment, take a second or two to do that. Now, area of triangle. Area of this triangle that we are having here, we are going to say this is going to be a half the base. The base is going to be 9 minus 6, which is going to be equals to 3. What's the height of this triangle? Is going to be the y coordinate of this point, and that's going to be equals to e is to 3. Then we are going to say, now our final answer is going to be 3 over 2 e is to 3. Then now we are going to say shaded region is going to be equals to 3e is to 3 minus 3. 3e is to 3 minus 3, subtract 3 over 2 e is to 3. Now, if you work out this, what are you going to get? This is 3 over 2, which is equivalent to 1.5. Subtract it from 3, so the final answer becomes 1.5 e is to 3, then minus 3. And now we ascertain this is the area of the shaded part. If you have found value from this particular video, consider subscribing so that in time I'm going to upload another tutorial, you'll be notified. See you in the next